We now have our index laws, we know how to play. Let's look at these things. Binomial products. Why are they called binomials? Well, bi means two, of course, and nomial means terms, things, maybe. Yeah, polynomial, many things. So a binomial product is a product of two binomials. In each parenthesis there are two things. X plus 6, x plus 1. Lots of different ways of doing this have been shown over the years. You've probably seen things called like the FOIL method, you know, the first outside, inside, last, things like that. The face method. You seen the face method? Let me show you the face method. Face method. It basically is sort of the FOIL method, but you actually draw things because it's more fun. So first, x times x is x squared. The outside ones, x times 1 is x. The inside ones, 6 times x is 6x. And the last ones is 6 times 1. And you know if you've done it correctly because you end up with a face. You see? The inside parentheses are the nose and the outside parentheses are the ears. You've got the smile, the chin, and there's your eyebrows. You see? Face method. Okay, let's tidy that up. X squared plus 7x plus 6. Mathematics is the science of patterns at the end of the day. And this is what we do. We look for patterns. And if we see a pattern that saves us time, we don't want to spend time doing the same thing over and over again. See, what we do is we will spend an inordinate amount of time looking for theorems and formulas and things like that. It could take us ages to find it. But of course, once we've found it, every calculation after that becomes very quick. And so that's what we do. This is what mathematicians do. So a plus b squared, we remember, is a squared plus 2ab plus b squared. A minus b squared, similar one, but it's minus 2ab. But to generalize that, you may or may not have realized it, it doesn't have to be a binomial, by the way. If you're squaring anything, you get each little bit squared, every one of them. So a squared, b squared, c squared, and so on. And you will get twice the product of all the possible combinations of two of them. So a times b, a times c, b times c, and so on and so on. Every possible combination will be in there. Difference of two squares, a squared minus b squared. Look, I just noticed how I set that out. It doesn't matter, of course, because you can multiply in any order, but it would have been more correct to put the a minus b before the a plus b, wouldn't it? Yeah, I'll show you why later. Okay, x plus 2 squared then. Now, I would not write this down, but this is what you're thinking, because you go, oh yeah, that's right, it's a plus b squared, so it's a squared plus twice ab plus b squared. In reality, we just write the answer down, x squared plus 4x plus 4. 3x minus 4 squared, bingo. As I say, we'd write it down. First one squared minus twice the product, last one squared. Difference of two squares, very good, the minus is in there first. 4p squared minus 25. Saving time. We're not expanding the whole thing out, we're using the pattern, we're using the formula. Well, here's a binomial times a trinomial. We don't have a nice neat formula. This is where I find actually drawing the lines is handy, because I think to myself, I know I'm going to have 2 terms in the first one times 3 terms in the second one. I should end up with 6 things. So I know I'm looking for 6 things. If I don't have 6 things, I've done something wrong. The answer will have 6. Let's do it. Okay, that's everything times a. There's everything times 2. Tidy it up and we have an answer. There we go. I'm now going to show you the method of detached coefficients. I'm going to expand this trinomial with this trinomial. One's a quadratic, one's a cubic. Yeah, sure, I could draw lines everywhere and so on, but this is how you do it. You write down all the coefficients of the first factor, starting with the highest power. The highest power is, of course, x cubed. Include any missing term. So you'll notice I have a 0 there for the x term. There is no x term in the first one. Okay. Now I will list all the coefficients of the second factor, again starting with the highest power. But you'll notice, even though the 3 is with the x squared, not the x cubed, I still start there. I don't line columns up like this is the x squared column, this is the x cubed column. It's just, no, start at the first one and just work to the end of the number, or the expression. 3, 4, negative 2. Okay. Then you multiply all of the first row by the first number in the second row. Okay, everything's times 3. Writing the first result under the first number. Right? So I multiplied everything by the 3, so I start under the 3. But now I'll multiply all of the first row by the second number in the second row. Okay? So I'm going to multiply everything by 4, but I will start writing it under the 4. 8 minus 16, 0, negative 20. You'll never guess what I'm now going to do. Well, maybe you would. So the third one, everything gets multiplied by negative 2, but I put it under the negative 2 columns. Now I just add down the columns. There is my answer. Well, it's the coefficients of all the answer. And so the highest power equals the highest power times the highest power. So where do I start with that 6? It's 6 what? Highest power times the highest power would be the x cubed times x6. So we've got 6x5 minus 4x4 minus 20x cubed minus 7x squared minus 20x plus 10. That is known as the method of detached coefficients. I found it in a textbook that was written in 1870, something like that. Yeah. That's the beautiful thing about maths. It doesn't change. Yeah, you can find lots of wonderful things in old textbooks that don't get taught anymore and things like that. A plus 2 times a squared minus 3a plus 7. So I would go 1 minus 3, 7. I usually find that, I know a plus 2 is the first one. It's usually the bigger one I'll write first. So 1 minus 3, 7. The next one's 1, 2. Remember, write that. Okay. Everything's going to be multiplied by 1. Everything's going to be multiplied by 2. Add down. There's my answer. Bang. Done. Very quick. See, you get something like this. Don't worry about the x and y's at the moment. It's the coefficients is what I'm interested in. So the first one, 3, 2, 0, 4, 2. Second one, 2, 0, negative 1. Now hang on, how did I know there was a missing term in the second one? Now let's look at these algebraic expressions. You'll notice in each of them, the powers add up to 4. All of them do. They're just different ones. So what am I doing? I'm starting with the x's to the power of 4. The numbers are going down by 1. Y's, the numbers are going up by 1. That's the pattern. Therefore, in the second one, there's a missing one. The xy is missing. So that's why this is 0 for there. Multiply everything by 2. Multiply everything by, well, I didn't worry about the 0 writing that down, because anything times 0. Multiply everything by negative 1. Add down. There is my answer. What would I start with? Well, I'll start with x to the power of 6, and now I know the powers of x are going down by 1, the powers of y are going up by 1. There's the answer. Now, whilst you might have thought originally that, hey, this method of detached coefficients, a bit cumbersome, I hope you can appreciate that is a heck of a lot quicker way of getting that answer. Yeah, try it with some. And look, it's like anything. You see a new method of doing something, just try it a few times. If you're comfortable with it, you might go, yeah, this is great, I'm going to keep doing it. If you're not, well, fine. You've got another way of doing it, do it the other way. It's whatever makes it easier for you. So 1B, I've asterisked 3 of them. They must be good. Yeah.